My name is Jason Wang. I'll be hosting the PIPC, your MC for the PIPC room. So our previous guests really spoke about some exciting topic on FinTech View, and I would like to introduce you to our next topic, how consumers win through big data and artificial intelligence. And to lead us on this discussion is Jay Van Zyl, founder of ecosystems.ai. Thank you.
Hi everybody, my name is Jay Van Zyl, long audience, Jay Van Zyl, Jay Van Zyl, in South Africa today. My topic is about the human organism as an algorithm, and I want to give you a glimpse of a story that we've been working on to attempt to understand how you can influence humans in various ways that are positive for their own outcomes. So I'm taking you through a bunch of cases. I'm going to show you some algorithms that I'm going to go through fairly fast. The idea is to give you a brief journey, and for those who are interested can get some of the content from me afterwards or from our website or somewhere where you can go download some of these things. But the big thing is just to talk about you and I as the human in the system and the role that that human plays when they are the recipients of all of these technologies that have been invented for us. So 3 parts to the story. First part is to talk about how the world's evolving, how things are changing, and the fact that there are what we call mega waves of change that are affecting our lives, and especially the wave we're moving into now, that has really got a big impact on how we do things. And then it's not about the AI itself. It's not about the analytic. It is about the intervention. It is about what you do with it and how you're going to influence somebody. So we have found that with some of the bigger clients we have in Southern Africa, we work with Vodafone on a continent with a bunch of cases in production and with Discovery and a few other banks in the country. We realize that it is all about that continuous engagement that is done through an intervention. It is the result of what you're analyzing, the result of what you are taking actions on, not just what you are looking at aesthetically. And I want to give you a glimpse of that with a few cases that are outside of the country, that are deeply embedded in the story. And then I want to give you a few pointers as to what the algorithms are. And I want to go through that fairly fast. So when I get there, just bear with the story. So let me start with a personal story. So if you think about how humans make decisions, at the end of the day, when a person is at a restaurant and they are wanting to pay for their meal, the purpose of being there is not to pay. The purpose of them being there is to enjoy the situation, the meal, the people around them, and the payment must be hidden, must be forgotten. It must be something that is completely seamless and totally easy. And sometimes we forget that if we do understand those decision points, and we do understand why those humans take certain actions, we have a far greater understanding. So imagine I was sitting with my family in California. That's what it looks like when you fly from the south over San Jose, looking up to San Francisco. And we said, well, we are sunset people. So we're going to move to a place temporarily until we decide otherwise. We spend some of our time where there are better sunsets. So we searched for the world's best sunsets, and a place in Cape Town popped up. So we said, well, we're going to make a decision to move to where the sunset is. And we packed up and we moved, and we now our commute back there every now and then. But the point is that a decision was made that no institution has any privy to. The only thing that you can infer is the fact that I used to transact at some place, I used to financially engage at some place, and then I changed my behavior. I am now doing it from a different location. I'm now doing it at a different time cycle. I'm doing different kinds of travel. I eat different kinds of food. I'm experiencing entirely a different kind of world. So I want to give you a brief story about that. But before we start, just listen to this, and then we can talk about how all of this plays out.
You do not know where your decisions come from. They pop up like hiccups. And when you make a decision, people have a great deal of anxiety about making decisions. Did I think this over long enough? Did I take enough data into consideration? And if you think it through, you find you never could take enough data into consideration. The data for a decision in any given situation is infinite. So what you do is, you go through the motions of thinking out what you will do about this. But warriors are people who think of all the variables beyond their control and what might happen.
Choice is the act of hesitation that we make before making a decision. It is a mental wobbling. And so we are always in a dither of doubt as to whether we're behaving the right way, doing the right thing, and so on and so forth, and lack a certain kind of self-confidence. And if you see you lack self-confidence, you will make mistakes through sheer fumbling. If you do have self-confidence, you may get away with doing entirely the wrong thing. You have to regard yourself as a cloud in the flesh, because you see, clouds never make mistakes. Did you ever see a cloud that was misshapen? Did you ever see a badly designed wave?
So think about it this way. The human biological system that is the recipient or the inventor or that participates in the economic system, each has its own ability, capabilities, fears, happiness, and all the other drivers that are often purely seen as somebody being a market or somebody being a consumer at the end of the day. The one thing that we do know is that you have been programmed to be absolutely obsessed with novelty. And that's the only thing that gives you excitement. That means that you want and you expect new products, new services, new ideas, new things all the time. You don't want to be trapped in something that's old or that is forgotten, or you want to forget the times that have gone by because there are great opportunities going forward. How do we capture that, and how do we learn? And are there algorithms that can give us some evidence that it's possible to influence what these humans think over time? So think about it in the humanities for a moment. When we try to understand the individual, we use neurosciences, psychology, and a number of principles, if I can call them those, that are essentially axioms or design mechanisms that were created by us observing humans and attempting to understand it. On the opposite end, if we want to understand a society, we use anthropology. So we want to understand how a society is going through shifts in its pains and its changing criteria over time. That gives you a view of its generationals, or at least a generational perspective of that to society. That is very different, by the way. So you cannot take a generation X from one generation in one country or one geography and apply it to another. Because in the Southern African region or the African or the European regions, each wave of change is very different. So how do you make sense of that, especially when you look at the data? And then in the middle, there's an interesting field, and that is called the collective. That is the person in their immediate setting, their family, their friends, the competitors that they compete with in business, the humans that they interact with. And if you can influence one, you can influence all. And you want to be able to track how they all integrate. And you want to be able to see the network effect and being able to live on the back of that. So the first thing we want to think about is what we call in the AI world the rate of learning and the cost of learning. So think about it this way. The rate of learning, if you run a mortgage business and you know that your customers, or are they clients, or are they consumers? Well, let's not talk about that just yet, but let's for now say that you do have customers. And those customers renew their mortgages every 2 years, and in other cases maybe every 5 years, and there are some people who pay their mortgage for the 20 years. And you want to be able to build a prediction as to how that human is going to behave when you offer them a new mortgage. Your rate of learning is incredibly slow. When I perform financial transactions and I buy a 5 Rand air bundle every single day, I drive through a toll gate every single day, I go to, pay my utilities, I do whatever I do, my rate of learning is incredibly fast. And yet we found a lot of people who are in the business don't take that into account. They don't really look at how the possibilities can play out when doing that. So if you think of the world in a few ways, before we could read or write as humans, our rate of learning was incredibly slow and the networks were very sparse. So if I live on one side of the planet and you live on another side of the planet, the ability for me to share what I'm going to share and us to then bring it together was incredibly costly and in most cases couldn't even happen. The second wave was the wave when we moved from reading and writing and global commerce. And that means that if I came up with an idea as to how I'm going to make you feel better, or how I'm going to solve a certain problem, or how I'm going to transact, or I can build something that you can finance, that means that I can increase the rate of learning. What truly transformed the world we're living in now, doesn't matter if it's through ledgers or through any other means of how we collect data, the rate and the pace of data generation is enormous. And that means that the accessibility is sitting at the same level. Look how excited people got. In our world, we were completely flabbergasted that people got excited about language models. Language models and natural language processing has been around for 50 years. And one day people woke up and said, look, this thing looks like me. It speaks like me. And now humans think it is a human. And all it is the next word probabilistic prediction engine that through the latent space figures out what a pattern is going to work for you using backpropagation algorithms to work out how it does the encoding and all those kind of things that most AI people should know about. But what really makes the difference? The difference is that the novelty about it is what you're excited about, not always just the utility. So how do you track all these data points and all these elements to make your own environment successful? So let's look at one of the first drivers. How do you get to know me? And what is the mechanism that you can use to get to know me? So I figured I had to throw in at least one business school, like a kind of a 3x3 in this context, but it's an Ansoff matrix that talks about new markets and new products, and everybody are always worried about how I'm going to conquer some new space because I need to acquire some new people buying my products and my services, and all of your companies worry about that. But then, now you want to think of the rate of learning. You want to be able to build prediction capabilities based on the data that you are collecting, but you sit with a slightly different problem now. Because if you continue to sell the things that you've always sold, and you continue to engage in the way you've always engaged, you collect data quite consistently in a normal way, and things just carry on as they normally are. But as soon as you launch a new product in an existing market, or you go and launch a new market with an existing product, you now have no data. So what we are deeply interested in and what we've been trying to figure out is that how can I deal with a human condition when there is no data points about the person accessible? How can I increase the rate of learning in a world where the rate of learning is so tough to capture? Because if you think about it, you're all familiar with large language models, with ChatGPT. It took 25 years worth of billions of people capturing the human contextual output, being language, stored it all over the planet for us to be able to get a model that can look and sometimes be useful unless it hallucinates or it comes up with what's known as a confident incorrect response. And you want to believe it even if it's not true. But the thing is that novelty is what we're now entering into the world of continuous engagement. Continuous engagement means that as I transact, can I in real time figure out what you're going to be doing next, where you're going to go next, what you're going to spend money on next, and what will excite you in the moment going forward. So let's talk about one or two cases. And I want to tackle a handful of these that you might all be familiar with, but let me just give you a glimpse of this. So if you think of a company like Spotify, think of a business like that in the context of, let's say, a bank, right? A bank does not have a product, actually. A bank has an inconsumable service. You make money not by a human coming to you once and leaving, nor does a payment switch, nor does anybody who operates in any space. You make money by that person staying engaged continuously with what you have to offer. And if you know that humans like novelty and excitement, what are you going to do to be able to capture that? So what Spotify did, they say, well, why don't we take all of what we do and turn it into data? And that means that make everything that sits under the covers accessible through APIs. You're all familiar with APIs, application programming interfaces. And if I want to know what a human is thinking in a certain suburb, at a certain moment, at a certain point in time, I want to know what they're listening to, what their behaviors are. All I might want to do is understand what kind of music they're consuming. Now, what makes it interesting as well about music is that it is totally embedded. It is very different than other kinds of media that you might buy over time. Because if you buy a monthly subscription to something, or you buy on the fly, what does that mean? That means that the economic customer and the participative customer in the Netflix or in the Spotify scenario are two different roles of people. The person out of the 500 million subscribers, the 500 million participants and the 200 million subscribers that you want to get to is a financial transaction to know that you have listened to my song for a certain amount of time and therefore you owe me a certain amount of money, but the first 10 seconds are considered a demo. Everything after that you must then pay me for. And then you embed it into watches, into phones, into running devices, into conference centers, into offices, and you then split it to almost all forms of consumption so that the participating customers, pay zero. It's not cheap, because remember that the distance between 0 and 1 is infinite. The distance between 0 and something being cheap is still infinite. If I have a 5 Rand data bundle that I want to buy this morning, and I go to the bank and I want to draw my 5 Rand, they said, no, I charged you 1 cent. I cannot buy it. So that means that there's something about the economics of free and a participative customer that these companies are attempting to figure out. Now, what makes it different? Is it, imagine taking every bit of music and turning it into data, into transactions. You carve it up into 3-second intervals, you index the entire music base that you have, and you then figure out the rhythm, the beat, the lyric, the tempo, and the pace. You create basically a signature for that kind of behavior, and you make it to the humans in the system that are going to be consuming that style of music. Nothing to do with a genre, nothing to do with the artist of any sort. Because if you're an artist who has never performed before and has just published your first song, and you don't have money for advertising, and you make a certain type of music, there probably is somebody out there that is interested in novel, new things that the match needs to be made. Okay, so that is what makes their algorithms more interesting. And that means that the AI needs to figure out continuously, not historically, continuously in that moment, what the best match is for you as you are about to enter the gym and you search for music, or you get a recommendation about what it is that you're going to be listening to next. So now what you then have is Spotify publish what's called your personality, right? So the personality is a background AI. It uses, for those who are interested, support vector machine, and then it uses t-SNE. That's a kind of an algorithm to work out clustering. Automatically does the clustering based on consumption behaviors as well as music around the world. It then creates and puts you into a certain, basically an archetype. And it dynamically moves you between archetypes as you shift your behaviors over time. Because there might be times when you have your 80s playlist and you're going to play some songs that give you nostalgia, and the rest of the time you might be the person that likes new stuff all the time. But it needs to know that, and it needs to know that you are an evolving being. Now, how do you make it practical? If you know that the people that can consume what you are providing are all sorts of providers, because it could be anybody. You could build your own music app and fulfill through the environment. So that means that wrapping all of what the payment system world has got to offer behind the scenes through their own payment API backend then gives you access through an identity system that is a personality that lives within the music world that is also your financial identity. And you know who the person is, and you know how they engage over time. So you could pick up if there are anomalous activity or anything else that happens within your space. But you get the picture, right? So that means that the embeddedness of you never having to see anything behind the scenes. You don't know who gets paid under what conditions. You just know that even if you participate, you get benefit. And if you are the economic participant, you also get benefit because there are many players in the overall. So that means that your business is nothing to do with music. It's all about data. And how you take the data and apply algorithms on your data, nobody in your business needs to know who the artists are. It makes no difference to anybody behind the scenes. Okay, so let's talk about some interventions. So the first thing, and this looks very technical, but let me give you a quick glimpse of how we see the world of analytics. And I'm sure that some of you are in the world of analytics, so let's break it up into kind of like three parts. We see the base layer of analytic, the ability to collect data and to report on it, and then your ability to create what we call pizzas and Manhattans. I'm not sure if you know those. Pie charts and bar graphs, right? So you put it into your thing called Excel that most people are these days pretty good at, and they draw a bunch of graphs and they say, check, I now understand the world. But the gap between you looking at the chart and knowing the outcome of the action you are about to take next is very disconnected. So the next layer is about predictive capabilities looking backward. Looking backward meaning making an assumption that the data that I have collected about you, about your activities, about all the things you have done historically, is representative of what you're going to be doing in the future. And that's the unfortunate thing about language models, about any AI model, is that if you are data dependent, you have to believe in the world of frozen identity. Because you freeze in time, in moment in time, all of what's happened up until that point when you train what's called train a model that eventually you're going to score against. And then you project into the future, you create some kind of extrapolation, thinking that nothing is ever going to change. The world we're moving into now is the world at the top, and that is the real-time world. And that means that can I continuously, as you engage, as you click that button, as you make that phone call, as you drive that car, as you go through that traffic light, as you go to the gym, everything that you do in that moment, know what the potential next set of actions are you're going to be taking, and if I can influence those or not. Okay, so traditional AI, just a quick definition for those who want to go study this. This means that it's a lot about classification and decision making based on some kind of predefined algorithms that are created for you. But as part of the wave of change, without looking at the detail of the slide, we come from essentially a long wave of changes and inventions in the AI world that has now got us into the world where what's called generative AI, that you might have heard of, is making an impact. And the biggest difference between discriminative AI and generative-based AI is that in a discriminative-based AI, if I have my camera on my phone that's going to detect my face and know that it's me, all the algorithm has to do is to know that it's a face and that it's yours, and then tell the infrastructure, yes, it is correct. That's discriminative-based AI. So that means that I have to ask it a question to classify, to organize, to give me an answer, yes or no. In a generative world, it's when the part of the AI engine gives you an output that is similar to what the input is. So if I give you language in, can you give me language out? If I give you an image in, can you give me an image out? If I give you voice wave sound in, can you give me a voice wave sound out? If I give you text and image in, can you give me text and image out? So that's essentially what generative means. But it still does not help you in the moment. It does not solve the problem of solving what it is that you're going to be doing next in this moment. So that means that generative AI is typically used for music and for, some kind of knowledge reproduction and for, a few other points that we found to be fairly useful, but mostly for offline. By the time you get to real time and you want to look forward, you need additional methods to assist you in using how that's going to work. At any slide, you have to throw in an architecture picture, isn't it? That's always when I deal with payments people, there's always an architecture somewhere, isn't it? So the AI Alliance, for those who are interested, you can go and look at this, but the AI Alliance published a kind of a blueprint of what an organization should have in its AI stack to compete. And it's hardly likely that you're going to find it with one tech provider, one cloud provider, one environment, because the entire capability that you need to experiment, to get your data ready, all the way through to get your models into what we call production, is a broader structure that you want to play out and a broader structure that you want to implement. And there are multiple players that's going to assist you to get to the outcome. That complicates the discipline, unfortunately. Okay, and then the variational autoencoder is an encoder that is used in deep learning. And anybody from deep learning, you can look at this and say, well, yeah, that's too basic. Yes, it is too basic. It's just for the rest of the people who want to see that there is a picture of a network graph that shows that there's a latent space where you extract the patterns of the data. And from the patterns of the data, you then figure out what's going to happen next. And you need lots and lots of expensive compute. So we might spend, just to give you an idea, to train a very big, even a language model that is highly purposeful for a certain domain, like fraud or so on, you might end up spending $10,000, $15,000 a day, for some cases 20 to 30 days at a time, just to train the base transformer for some of those kind of models. So that means the cost of training and the cost of your learning eventually is a massive driver for us to figure out what the capabilities are that you want to implement. Okay, let's talk about another case. And for those who know Uber, you probably know Uber Eats, and the various companies within the group. There are 21 companies in the group as a whole, but let's just talk about one part of that with Uber Eats and their payment system backbone. And the idea is just to see how a complex network can be constructed. So if you think about it, ordering food and getting it delivered around the world is a big focus for many of the companies who provide any kind of human-to-human connection, including Airbnb and so on, are getting into the food delivery business. The other part that is challenging is how do I deal with cash in the system? And in the South African context or the African context or emerging market context around the world, that is a massive problem. So you need to provide ways for people to identify themselves, and AI plays a massive role in that space. Can I identify who you are, where you're engaging? Can I see if you are going to perform something that is fraudulent or not? So that means that getting what I have to offer to you is part of the big issue in these companies. So let me talk about how they did various players in the field and brought them together. So the first thing is, if you think of Uber in the middle of their own payments network, every provider, and it doesn't matter if it's a restaurant or a competitor even, you now have an ability to do what's called deep app linking or deep payment linking. So that means that you can clear in one place and pay in another place within your own network. There only has to be one entry point, and the wallet can be shifted between any of the players in the organization. And why you do that is because you can control what we call the three parts of how we see a lot of the AI. Making money, so that means how do you make money in the system, so you can control the transactions. How do you save money? So that means that can you do it efficiently so that the hops are controlled by you? And then can you protect money? So that means can you deal with the fraudulent activities that you can control within your network? Okay, so let's tackle one more case. I know, listen, today is a lot about cases, but you all know IKEA as an organization. So maybe just to describe what it is. So IKEA is a company that has shifted the value constellation of the acts of assembly from the manufacturer to your home. So that means that the ability to take well-designed furniture and move it, the act of the assembly process to you, is the primary value proposition of this business. You might think, well, how can it be a value proposition? But if you live in highly densely populated parts of the world, it's very difficult to get furniture shipped from a store to your house. So you could buy a dining room table or you could buy a kitchen and it'll fit into the trunk of your car after you've done maybe a few trips. But the point is it gets flat packed, it gets packed in a way that you can assemble it, and it's pretty well priced and well designed. Now, because your design system is that your retail and your manufacturing is at the same place, how now do you deal with getting people to come to your facility if the cost of them getting to you is pretty high? So they created a concept called you buy with your time. So what you do is that if you have to travel a certain distance to get to the store, all that you have to do is take your Google Earth from destination at your home to the store, and you get paid for the amount of miles that you've traveled that comes off your account if you buy any furniture in the store. And I found that it was still worth doing that rather than creating additional infrastructure to service the people who are normally moving around to go and buy some of the products that they provide. So there's a financial system designed where time is the currency. So what you want to do then, and if you think of the chart on the left as how they use a construct to say, how do I take dreaming all the way through to the point where I see what action you're taking? So the IKEA catalog has become one of the world's best magazines, design magazines. So people will hang on to it. But there's a code that you type in when you go into the digital world, when you go search for which store it's at, or you want to go buy something online, that you immediately can track where that catalog was distributed, who the person is that has captured it first, what payment mechanism they eventually used, how they acquired the product. So the intelligence that you track is bringing what we call the hyperlocal world into the virtual world. We see this as a massive obsession, and that's why you see that Uber and Amazon and everybody are interested in knowing where that human is physically present when they transact, because you want to control that entire pipe of activity that sits behind the scenes. So that was the easy part. For those who are interested in algorithms, and I know that it's just before lunch and it's going to be, a sleepy session. I'm going to take you through this fairly quickly. I want to give you just a high-level view of some of the ways in which the thinking is developed. And these are all algorithms that are implemented already. They are in production. They are delivering value. So I'm going to just give you a quick view of that. Okay, so let's think of the first construct. In the moment scenarios and how you should think about this, if you drive a motor car and there's an alarm in your motor car on your dashboard that says you're exceeding the speed limit, or there's a car that's going to hit you and there's a probability of a collision, the human action still needs to be taken into account. So that means the alarm is what you see in your company as a dashboard. And I'm sure you've seen dashboards and you have to make the decision. What we're seeing is that the world of digital twins is now changing the way we see things. And that means that can I operate the business? Can I operate what's going on in parallel? And then intervene at the right moment. So if I can avoid a collision by swerving the motor car in real time without giving an alarm to the driver, I'm taking some of the actions that could be taken away from the human if I can keep the human safe. Everybody okay with a construct? Okay, so that's the difference between an analytic, even if it's predictive, and an intervention that is predictive. Okay, so in the banking world, we think of, relationships and how we deal with everything digitally, and I'm sure you've seen these kind of charts, before. If you haven't, they're pretty well published around how we see the transaction layer versus the relationship need for by the time I get through credit and my wealth cycle. But it's about what kind of AI gets deployed, because the AI in a transactional system is very different than what you use in the wealth world or what you use in your credit world. They are not even remotely the same, because you deal with fine-grained continuous interactions, and you need to see that differently. So that means the real-time nudging and real-time intervention, personal recommendations, all happen far more closely in time than what you would see in any other parts of any kind of financial environment. Okay, so that kind of sets the context. So let's think of an engagement algorithm, right? So this is how it goes. If I know where and how you spend what you spend, I can use that to extract your behaviors, and I can work out the pulse of your engagement over time. The pulse of engagement is how repetitive you perform certain actions. So if you are an intentional spender, I can see that you intentionally spend with the same amount of money the same way over and over again. You put fuel in at the same fuel station, you buy food at the same place, you engage in continuously the same way, and I can then work out from the behaviors almost everything else about you. I can work out if there's anomalous-based activity, or if I can sell you something else. If I want to get a partner in a system or recommend an alternative product or alternative route that you must travel to go past somebody that I want you to go past, all of that can be affected if I understand your behavior. Then I can drive my campaigning by geospatially mapping you onto the location or the geographical location where you're actually performing the activity you're performing. I want to work out where you're traveling, how you're traveling, and at what pace you're traveling at. Then I can calculate all the other things. So if you think of the problem of churn and attrition that a lot of companies kind of think about, the purpose of predicting churn is to sell more. Once you have that mindset, then what you start doing is not giving you a discount when a person is about to leave you. You figure out that your pace of engagement is probably incorrect. The messaging that you're using, the price point that you're doing things at need to be reconsidered. And you want to be able to adjust that by doing it automatically. And then dealing with how you drive all the other capabilities that you then have beyond it. So there are a whole lot of different predictions that you can make, that all these predictions assist you along the way to make better decisions. And that means that by the time you construct your geospatial view, you should know the actions and the pulse of behaviors. And I can give you a South African example. It's an interesting one. We call it the time, place, and act. It's a three-part vector you always track in all of the predictions. So I want to know what happens to you in April and December. I want to know that when you go on holiday, why you go on holiday, when you leave the country to visit a family, when you don't, what kind of money you spend, what kind of food you eat, what kind of car you drive. Everything about that situation is visible through the rails. You have access to all of it, because you can predict the entire societal shift that happens, and especially in ritualistic countries like South Africa that are deeply ritualistic. Okay, so let's look at the spending personality. A couple of simple steps if you want to build one yourself. I figured I'll give you the formula. You just develop a personality construct, and then you have an hypothesis for some indicators. You apply a couple of disciplines, and you can come up with one. It's simple 2 steps. Then what you do is you can then use archetypal data through your transactional capabilities, map that back to a human social system, and you can figure out what those humans are going to be doing. Okay? So what you then end up with is how you then cluster their common behaviors. You find out what kind of human performs what kind of activity, and you figure out which activities are mutually inclusive versus exclusive. Mutually exclusive is that I cannot drive the Uber and put in fuel on my own car at the same time. And cannot do certain things. That means that there are certain activities that are based on your biological physical system, not possible. You don't need an AI to tell you that. Then you need the AI to tell you the correlations between the rate and the pace of how people engage and the money that they spend and how frequently they engage through that entire cycle. And eventually, what you do, you now want to work out how the human interact. And by the time you do an interaction, it looks something like this. And that means that I want to know the difference between, let's say, an intentional person and an experiential person. And you can do this own test yourself in your mind. When you go to your digital channel, or you go to the store, or you go anywhere when you want to go financially engage, remember, you don't go anywhere to financially engage, you go somewhere to do something that eventually going to get a financial engagement. And you are highly intentional, it means that you want a single-step action. I want to go to a digital app, I want to click one button, must be done. I want to go to a store, I want to find the shelf, I want to pay, I want to leave. I'm intentional. If I'm experiential, I will love to be distracted. I'm the one that clicks on the buttons on the side of the menus that appear, that is giving me recommendations, and then get sidetracked and forget what I wanted to buy in the first place, come back the next day and try it again. Very different personality types that can be tracked, and you can adjust your entire digital engagement ecosystem based on those personalities. So that means that this is a classical example of an experiential. Each green dot is the time that a person is clicking or acting on something. This could be on a phone call, by the way. It could be on a digital channel. It could even be in a physical environment. We find that the patterns are very much the same depending on what kind of situation you are in. This is what an enthusiastic customer looks like. They are highly engaging. They click everywhere, they guide, they give comments, they give feedbacks, they even rate your products. You can see that they are very, very engaged. But then you get the intentional. Every time you put an obstacle in their way, they get annoyed, they get irritated, they might even leave your environment. And when you design, normally, if you think about it, when people design their digital environments, they make an assumption that there's a concept called a persona, and it never includes the most basic behavioral traits that most companies, or that most people have, and that most companies don't agree to. Okay. The last bit, before I close up, is to talk about what's called the sentimental equilibrium. And this is a very exciting piece of research for us. We took research that was done around spousal relationships and why they failed. We didn't do the research, but we partnered with some researchers who did a psychological study on why partners, after long periods of time, or some cases short periods of time, decided to part ways. And the outcome was because of a concept called an effort in attention. Because the effort that goes in when you meet the person a first time with a level of emotional excitement is high. And that's why you see that all of what happens to you in your digital world, in the restaurants that you go to, in the cars that you buy, in the clothes that you buy, in the places that you go to, the speakers that you listen to, you want new things. And that means that if you want an old thing to work, the person has to put in so much more effort to be relevant. So what you do now is that you take all of the algorithms that you figured out around humans behave, and you can automatically calculate that. Let me give you an example of attrition. That's a great place where you can implement it. Can I make an assumption that if you do not spend money on food with my card, that you are not eating? All I know is that you're probably spending it with somebody else. Now, what if you used to spend money on food with my card? What if my card was embedded in your Netflix, in your Spotify, in your LinkedIn account, in your Apple Payments account, in your Google Pay account, and now it's not? What made you take that decision to remove it? What was involved in the cognition that got you to remove them? Somebody else had to convince you to stop using what you have to offer. So we have found that there's an enormous amount of activity that can be analyzed and can be predicted and can be influenced if you just follow the line of reasoning to say that this human out there is a biological system. And it has got certain needs. And you must never forget that. When you superimpose that on top of your data and your algorithms, you see an entirely new world. Not just a world that is filled with math or with some kind of extrapolation that is entirely generic. Because you can't say that, let's say that you've collected data over the last 2 years and none of your customers have ever bought food on your card. You can say that none of the humans that we service eat. That's what will happen if you take classical analytics and apply it. So part of my call to action for you today is that the unfortunate thing with classical analytic and big data is it gives you the wrong answers. You still need to understand the context within which you're going to be analyzing what you're analyzing. So this is kind of a summary for the story. So the first thing is you have to understand the evolving human in that system. And the evolving human is that new things come along and you want to be able to track the behavioral changes. And we found that, especially with telcos on the continent, we've learned an enormous amount. I mean, with one client, we've got 130 million people that we track on a daily basis. We run 15 million experiments a day. 15 million experiments per day to know what you might or might not engage with next. Your rate of learning is done through high degrees of engagement. And even then, we still don't get it right all the time. Now, I imagine if you take 1 year's latest data and think that you're going to understand how people are going to behave the next year, how slow that's going to be. In some cases, irrelevant that's going to be. The next thing is that when you design an intervention, make sure that your intelligence-based technology is there to drive the actions, is there to assist with an intervention, because the cost of execution is directly tied to the humans that often are in the system that create the error and the slowness of execution. And then lastly, when you implement algorithms, there are so many available. This means that you cannot just take the classics. You cannot just take the simple things that you think are going to work. We now see that humanistic algorithms on top of the math is what gives you a very, very different perspective, hopefully making it far more successful than what you would have seen under normal conditions and other ways. Okay, so that's, I guess, my story for today. So if there are any questions, if we've got time, we can work through those.
Thank you. Thank you, Jay. Are there any questions for Jay? Yes, there's a mic.
Hi, Jay. So I've had the benefit of playing around with machine learning and AI, using a system where we had a 4-eye principle, determining an outcome and ensuring a human on the one side of the eyes, with AI and machine learning determining whether the same outcome would come. One of the things that we picked up, and maybe it's a statement as well as a question, is what we picked up is unnecessary bias.
Sure.
On the AI side of it. So, for example, and I'll use a simple example without being too offensive, we would checking to your commentary about somebody going through robots and moving through robots, we would see somebody with brown hair and glasses.
Sure.
The AI solution would see that would start pointing to that being the problem,
sure,
which was a bias, which wasn't necessarily what we were looking at. So I think the statement is be careful. Sometimes whatever you've got from the AI can cause that bias, and you need to just make sure that you recalibrate. And then the second time, is there a way of automating to try and eliminate that type of bias within the system?
I think maybe just to make sure we all understand on the outset, there is no algorithm that's got bias. Let's just make sure we understand that. That an algorithm only behaves in a way that you have given it a certain data or an embedding to behave on. So if your models that you have trained and the algorithms that you've used have got bias, then you've got a very, very, very different crisis than I think that most people even understand. We have never seen algorithms with bias. The data contains the bias. And actually, in fact, there's a classical example. We worked with a company who do an analysis on male tennis players. If you have to understand the velocity of how a ball gets hit, the number of times there's an out on doubles, singles in tennis, in a male tennis match, and you want to score a female game against that, it's got male bias. So let's make sure we understand just the story. So if you have got an algorithm that is giving you bias, it means that whoever prepared your data is where your crisis is. Because unless they used an algorithm that might have been created that is problematic. But if you have a tree-based method, and if you have historically only sold certain products to certain markets, then by default you're going to get a bias-based approach. So, and that's what I think would make a lot of the implementation a lot more complicated, because people think that it is just the algorithmic, it's the AI that's biased. But you need to think of the entire pipeline of activity. It's quite important to remember that difference. Yeah.
Great. Is there another? Yes.
I just want to ask a question about the assumption of everybody wanting novelty. Is that always really, I mean, don't people prefer familiarity sometimes?
Of course. I mean, it was more of a tongue-in-cheek, exaggeration, but you will at some point change something, even if you're on that continuum. And you find that there's also a biological age related to what people like in the context of change and what not. So you find that when a person has got no preference of a certain situation, everything is considered novel in the world of engagement. Like if you've never had a mobile phone before, and now you get a phone. If you've never owned a motor car before and you get a motor car. If you've never worn clothes, well, that's maybe a tough one. But if at some point you get given something that is new in category, that's also novel. So it doesn't matter what age you're at. So if you've used ChatGPT, I don't know if you have, or the first time you've used Google search, that was novel. So all humans at some point will be exposed to something that is new and novel to them. What we are saying is that once you get that and you can see that it's working for you, you want more of it. And it doesn't mean that you are at the leading edge of it, but there are some people that are on the leading edge of it. But that's why music for us has been such a great construct to work with. Because if you think of music, there are some people, I've got a friend who only listens to the 80s. That's it. So that means that novelty means that maybe somebody has mixed some old song. For me, I like lots of new stuff. I like chill hop and all the new genres. So the algorithm needs to know what novel means for one versus another. So that is the idea. So it is kind of an exaggeration, but we do see that if you use the concept of the fact that people like new things, you can track it in what food they buy, and especially at the transactional level, it's very, very vivid. Especially when somebody has just got a new car or they got something that's new. They travel to a new destinations. They've been to a new holiday. You can see changes in behaviors. It's considered novel. So that's how the definition plays out.
Great. There's one more question there. So.
Hi there, Jay.
Hi, Lindy.
Why would you say that real time is the edge? Because at least what I've taken away from today is real time is the future. You can't react after the fact.
The reason is that because of your shifting behavior that is happening in that moment, and especially with most of the actions that you're going to perform over the next period of time. So, and again, let's come back to the issue of what's novel, what's not. There are some people who would work out for another month in advance exactly which restaurant they're going to go to every 2 days. You then slot it into your calendar. Let me play out a story. Then what you do is you're going to say, yes, my car's going to run out of fuel on Friday, so I'm going to go Friday to this particular fuel station, next Friday to that fuel station. Then I'm going to be able to like this kind of music by Wednesday because there's going to be some song that I'm going to be listening to on Wednesday morning. Then I will be going to the gym every day at this exact time. And along the way, I will, stop at a street vendor and buy the following, and I then slot it out for a month in advance. And I perform that exact set of actions the last month, 2 months, 3 months, year. Even the humans that are the most ritualistic don't do that. Now, do the mental test. Tell me exactly how many times have you put in fuel with which fuel station in the last 2 months, what amount did you pay, and did you then buy food at around about the same time, and then did you pay for a service while you were at it, and give me the detail of that over the last month. So there's something about short cycle learned activity that humans do not remember. But if I had to ask you, when last did you go on a great holiday to some exotic destination? You might remember the exact date. What is your wedding anniversary? What is your birthday? Oh, you remember those. But as soon as it's got to do with anything that's got to do with continuous engagement, you don't remember. And that is the challenge. And that means that real time could mean near real time. It could mean that I just want to know what you're going to be doing the next day or two. And because your rituals change over time, how do I predict that? You know, Netflix ran a study, and this is maybe a last story. I know we're completely out of time, but you know, Netflix ran this prediction study through Kaggle a couple of years ago. And the problem was that can I work out what kind of media people listen to or watch all the time? And then what you do is you design what's called a cliffhanger. You make the closing of one episode the opening of the next episode. Why? To keep your attention. Because if you change your attention to something else and they offer something better, you might cancel my subscription and go to, you know, Apple or, you know, to any of the other kind of providers. So how do I keep you then in the system? Now there's a scenario of an elderly lady who once a year watched the X Games for a week solid. So X Games, why would an 89-year-old watch the X Games once a year for a week? Should I see it as an anomaly? Should I have a forgetfulness function to say that let's just forget about that and just recommend it at the time? How do I deal with that in my data set? Because my data set is classically biased to all the other things that she's watching, not watching X Games. It turns out that the human event was that her grandson visited once a year for a week. And, oh, I see somebody got it. And watched it. Now the question is, how does AI deal with the attention problem? Can't. It sees it as an anomaly. And that's why most of the algorithms, including deep learning, will not predict that ritual that happens once a year, even if it's for. Now the question is, if the kid turns 20 and they switch from X Games to golf, what happens then? At what point are you going to say, well, hang on, I'm going to take the last 5 years of this kid watching it and I'm going to then peg it as one of the anomalies. But what about all the other humans who watch certain things in different ways? And that's why the in the moment is trying to figure out all the other behaviors that go alongside it. So they realize that if the image, like a Netflix, of the movie that you see for your profile changes, your behavior changes. So once a year, you then test if the grandmother is already preparing and watching some of the X Games by the time her grandson gets there to watch. So you could see the behavior leading up to the actual event then happening then over another few days. So that complicates the in-the-moment problem because of the issue of attention, because that is the Holy Grail, keeping attention. Yeah.